Okay, ladies and gentlemen, we're going to start off today taking a look at Chemquest 9 here. Our first problem, neon has three different isotopes. 90.51% of neon has atoms that have a mass of 19.992. Alright, so that tells you these two numbers go together. We also have 0.27% of neon atoms with a mass of 20.994 AMUs. And then finally, we have 9.22% with a mass of 21.99 AMUs. And they want us to find the average atomic mass of neon. So what we're going to need to do is to set up our equation where we use the mass of our first isotope times the abundance. I'm just going to abbreviate AB. That's abundance of our first isotope. We're going to multiply those together and add them to the mass of our second isotope times the abundance of our second isotope, and add that to the mass of our third isotope times the abundance of our third isotope. Okay, so that looks like 19.992 AMU, and I'm going to leave the units off, times 90.51%. And we're going to write that as a decimal. I have to move this two places to the left. That's 0.9051, and I'm going to add that. Mass number 2, 20.994 AMU times 0.27%. Got to go two places, 1, 2, so that's going to be 0.0027. So 0.0027, and I'm going to add that to my third mass, 21.991 AMUs times, going to go 1, 2 places to the left, so 0.0922. Alright, so these are my abundance written as a decimal or a fraction form. Got my three masses. All I need to do is punch this into my calculator now. $19.992 times 0.9051, and I get 18. I've got 5 significant figures and 4 significant figures, so I'm going to stop at 4. 18.09 AMU plus 20.994 times 0.0027, let's see, I've got 1, 2, 3, 4, 5, and 2 significant figures. So this one's going to end up being 0.057 AMUs. And then my last one, 21.991 times 0.0922 equals 2. Let's see, 1, 2, 3, 4, 5, 1, 2, 3 significant figures, 2.03 AMUs. Now I go to the hundredths place, the thousandths place, and the hundredths place. So my final answer should be the hundredths place. 18.09 plus 0.057 plus 2.03. And that's 20.18 AMU. Now to check my work, I should make sure my final answer is somewhere between these lowest number, 19.92, and the highest number, 21.99. So it's about 20, and we can see that 90% of the neon is about 20, and we're really close to 20. So that would make sense with our prediction. Alright, here's problem number 2. Chlorine 35 has one isotope of chlorine 35, it's its mass number. Chlorine 37 is another isotope of chlorine. How many protons and how many neutrons are in each isotope of chlorine? So for this problem, I'm going to go to the periodic table and I'm going to find chlorine right here. It's got an atomic number of 17, which tells us chlorine atoms always have 17 protons. So for chlorine 35, we have 17 protons. And how many neutrons? Well, if I were to write this as the nuclear notation, it'd be chlorine 35 over 17. And I can just subtract 35 minus 17 to get 18 neutrons. 17 protons and 18 neutrons. Now for chlorine 37, I'm going to write that one over here. Chlorine 37 over 17. I still have 17 protons, and this time I've got a mass number that's 2 bigger, or 2 more neutrons. So that's 20 neutrons. Number 7, of all the chlorine atoms, we have 75% chlorine 35 with a mass. So this mass and this percent abundance go together. And the other chlorine atoms, I'm going to circle this one, have a mass of 36. But what's their percentage? I don't see it on here. I'll need to know the percentage in order to find average atomic mass, or I'll need to know the abundance. So I'm going to set this guy up by filling in what I know. 75% times 34.96. So I'll write 0.75771 multiplied by the mass, 34.96885, and I'm going to add that to the other percentage. Now what is the other percentage not given? I'm going to do that math over here. I'm going to say 1 minus 0.75771, 1 minus 0.75771 equals 0.24229. So this is the fraction that is not chlorine 35. The 1 represents 100%, and these decimals represent the fractions of each isotope. So I'm going to write this one here, 0.24229 times my mass, 36.96590. All right, do a little calculations. You can see I have a lot of significant figures here, way more than this side. I have 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5, 6, 7. So I'm going to stop at 5 in both cases. So 0.75771 times 34.96885. We have 26.496. And we're going to add that 0.24229 times 36.96. 590 is 8.9565. One, two, three, four, five significant figures. Now we can see this one goes out 4 places to the right of the decimal. This one only goes out 3 places to the right of the decimal. So I'm going to go ahead and stop at 3 places to the right of the decimal. 26.496 plus 8.9565 equals 35.453. AMU. Do questions 5 and 7 agree with the average atomic mass for neon and chlorine on the periodic table? Well, chlorine is here, 35.453. That's pretty good. And up here I have neon. Oops, let's see if I can pull this down. 20.18, and here I have 20.180. So we're doing okay. All right, on the back here we have nuclear symbols to deal with. All right, so the easiest thing to fill in first when you look at a nuclear symbol is the number of protons, 15. It's always the bottom left number, the atomic number. Phosphorus is always 15. All right, I'm going to fill this number in for aluminum as well. That's 13. For tin, it's 50. Now I've got down here an 84. So I know the 84 goes here, and this 7 goes down here. So the bottom left corner is the atomic number. How do I decide what symbols to write here? These two things are associated. Here's tin, 50. Tin, 50. Aluminum, 13. Aluminum, 13. So I'm going to look for the 7 and the 84. There's the 7, that's nitrogen. So I'll put an N here. Now I'm going to find the 84. 84 is polonium, PO. All right, what's next? Some of the things that we've learned about charges would be helpful here. Phosphorus has no charge, which tells us the number of protons equals the number of electrons. All right, aluminum has a positive 13 protons, and it has a charge of plus 3. So for the number of electrons here, I must have fewer electrons than protons. In other words, 3 more protons to give me that 3 extra charges. So I compare 13, I say, what's 3 less? That's 10. All right, tin here, no charge. The number of protons equals the number of electrons. I should back up here to aluminum and give you a little hint. If you're working on this, you can always put a plus here and a minus here to remind yourself I have 13 positives, 10 negatives. If I put those together, I'm going to have 3 pluses. Just a little reminder for myself. All right, polonium. It's telling me 84 and 84, so I'm not going to put any charge in there. And then nitrogen, 7 and 10. This is the negative. This is the positive. I have 10 negatives and 7 positives. That's 3 more negatives. Okay. What's next? Number of neutrons. Oh, wait a minute. Take a look here. We have numbers of protons, number of electrons, atomic number. Atomic number and number of protons are the same thing. So I'm just going to go down and fill this column in for that column, 50, 84, 84, 7, 7, and that gives me the number of protons here is 38. So I can go back to my periodic table and say, who's got 38 protons? Sr, strontium, 38 protons. It also has 38 electrons, so no charge. Alright, so far I've got my atomic number, my number of protons, my number of electrons, and my charges all done. So all I have left are these two last columns, neutrons and mass number. These two things are closely related. The mass number equals the number of neutrons plus the number of protons, 15. And that 15 goes right here. 210 is already given to me, so the 210 goes there, and I just have to do a little subtraction. 210 minus 84 should tell me the number of neutrons. 210 minus 84, 126. So 119 minus 50, 69 neutrons, mass number 119. 80 is the mass number, so 80 goes here. 80 minus 38, 42 neutrons. Mass number 28, 28 minus 13 is my number of neutrons, 15. And then I have 31 in my symbol. 31 is my mass number. 31 minus 15 is 16 neutrons. Alright, here's number 10. A certain element has two isotopes. One isotope has the abundance of 72.15% and a mass of 84.9118. The other has a mass of 86, but there's no percentage. So I'm going to do that same thing I did before. This time I'm going to start with 100, and I'm going to subtract the 72.15. And instead of starting with 1 and subtracting 0.72, so I've got 27.85. So 27.85%. So I've circled my two that are related, mass and percent. I've underlined the two that are related, percent and mass. So now I can plug these guys in. My first mass is 84.9118. And my first percentage is 0.7215. Remember, 1, 2 decimal places to the right. Multiply those guys and add them to 86.9092 times 1, 2 to the right, 0.2785. Plug in the numbers, 84.9118 times 0.7215. I have 61 point, let's see, 1, 2, 3, 4, oof, way too many. 1, 2, 3, 4 is all I need. 61.26. All right, and on the other side, 86.9092 times 0.2785 equals 24 point, let's see, I need 4 sig fig, so 24.20. Add these guys together, 61.26 plus 24.20, and I get 85.46. 2 to the right of the decimal, 2 to the right of the decimal, so I'm just making sure I'm following my rules for sig figs there. Alright, here's our last problem. This one's written for us in a table form. That works really well for me because now I can just do something like this. 23.985 times 0.7870. Take 24.986 times 0.1013 and 25.983 times 0.1117. Notice I move these all 2 places to the left or divided by 100 to change my decimals into percents. Okay, now I need some answers here. So do all these calculations. 23.985 times 0.7870, and I need to go 1, 2, 3, 4 significant figures, 18.88. 24.986 times 0.1013 equals 2.531. And 25.983 times 0.1117 equals 2.902. Add these guys together, and you can see we're going to round to the hundredths place, 2 to the right of the decimal. 2.531 plus 2.902. 24.31 AMU. Alright, and then I just check to make sure my mass is somewhere between 23.9 and 25.9, and it is, and then I check my percentages. Most abundant was 78%, 79%, 23.9, so I'm pretty close to 23.9. Not bad. I should do that, repeat that same thing for this problem up here. I got 85.46, somewhere in between 84.9 and 86.92, just to make sure my average is in the middle. And we had 72% was our most common, so it should be closer to 84.9 than it is to 86.9, and it looks like it is. All right.